So there you have it, folks. Of the three types of conventional high flow water filtration, the most popular unit, sand filter. It's a machine. Filter, backwash, just a valve change. No filter cartridges to clean or replace. No sacrificial media to pre-coat the filter. It's simple to run, it's automatable. But we've got these incredible inefficiencies I demonstrated to you, both on the filtration cycle as well as the backwash cycle. Not to mention we've got flow-related problems where the media grains all start to shift. So let's build a better permanent media backwash filter. Let's first get rid of the shifting problems, the low flow channel, high flow channel, tanks out of level. Let's get rid of that. We're going away from gravity. Let's mechanically compact the media between stainless steel screens. So we'll take our granular filtration media, put it behind a screen and put mechanical force on it and hold it fixed so it can't shift at minimum void, and all our flow related problems just went away. Now, next problem. We need more water flow and a higher appetite for contaminants so we can handle these extreme situations, like oil field reclaim on frack water. How do you do that? Well, if you look at this illustration of the granular media sand filter, I've illustrated the active media red and the inactive brown. You got a lot of inactive brown media out there. And you know what else? The flow rate and appetite for contaminant are determined strictly by the surface area of the media body, which is two-dimensional. How do we fix that? We have the birth of radial flow filtration. We go to 3 dimensions. We go from this design to a hollow sphere. We mechanically compact the catch of granular media now into a hollow sphere, in the process tripling the surface area of the media body, which resultantly triples the flow rate and the appetite for contaminant. It looks like this. Inside the machine, the granular media is in jail. It's captivated between 2 huge perforated hemispheres that compacted into another sphere that's smaller. So you have controlled bed depth, mechanically compacted. The incoming water comes in and envelops the sphere, 3 times bigger now. So you have 3 times the flow rate. And the filtration occurs on an accelerated flow path through the mechanically compacted granular media. It's collected at the inner drain and works better. No malfunctions. I just tripled the flow rate. I just tripled the appetite for contaminant. When you do the math on this, it's pretty impressive. This picture here is drawn to scale, and you can see those 2 small radial flow filters are actually supplying the same amount of product water as the big horizontal sand filter in the picture. And so now you're asking me, what's this machine look like? How does it do this? Inside the tank, we have the radial flow filter. Basically 2 colander-like hemispheres perforated that are squeezing and compacting the media against the inner drain. What's the inner drain? Smaller perforated sphere inside of that one. Now we've got controlled bed depth, minimum void, everything held solid, triple surface area. Everything's wonderful. We didn't solve one problem. The inefficiency of backwash I showed you was sand. That slow, lethargic, half inch per second velocity that's supposed to clean the grains. You couldn't wash your car with water going that slow. What do we do about it? Inside the inner drain, we have our backwash jets. We have a Gatling gun of spa jets delivering water in the backwash cycle. Now remember, we've uncompacted the media, it's fluidized, but it's still captivated. We've got these Gatling guns of spa jets hitting it at 16 feet per second, 250 times the velocity of the slow conventional sand filter. Our backwash cycle went from 3 to 5 to 10 to 20 minutes of the conventional down to 20 to 30 seconds. Fast, saves over 90% of the wash water required. Anyway, next step, let's go over, I'm going to show you the radial flow filter that we've got in operation here. We built our alpha prototype radial flow filter out of a Stay-Right Industries System 3 sand filter tank, 24 inches in diameter. Now if you look at the spec sheet on the side of that filter tank, it's rated for a maximum flow rate of 68.5 gallons per minute. With the radial flow, we had to plumb it with 3-inch bulkheads, and we were able to test successfully up to 210 gallons per minute, over 3 times the flow rate. We're going to run it right now, and today, due to the limitations of my pump capacity, we're only able to run at 165 gallons per minute, which you'll see on the flow meter. And we're doing that with 2 pumps. So first I'm going to kick on the main pump, and we'll come up to over 100 gallons per minute. Then I'm going to kick on the booster pump, and we should peak out right around 165 gallons per minute. Now we're going to step over to the radial flow filter alpha prototype. I'm going to put it through the backwash cycle. It has a position indicator on the top, and you can see the media container move up and down when it goes from filter to backwash and back to filter. Let's go over there next. Now we have the radial flow filter alpha prototype up and running, as you saw, at 165 gallons per minute. I'm going to switch the backwash valves, reverse the flow, put it into backwash cycle, and you can see the media container position indicator come up. Then I'll go back to filter, then it'll go back down. We're going to do that twice so you can see this here, as well as see the media container move inside the window. Then we're going to take it apart and show you how it's built. So here we go, we're in filter. Now we're in backwash. Up comes the media container. Up comes the position indicator. Back down to normal flow. Back down in position again. One more time in case that was too quick for you. Backwash, all the way up, going back to filter, all the way down. Radial flow filters work best in banked installations, multiple filters, and let them backwash sequentially with what we call pulse backwash. They backwash very fast, and when there's a multiple installation, they actually use the clean water from the other filters that are still online. So we have a demonstration set up here with 2 conventional filters that can backwash each other with clean water from the one that's still online. We've got air in the water so you can see the flow coming in, being split onto the 2 filters, through the 2 filters, back to a collector line, back to the system. So what we're going to do is we're going to stop the flow into the first filter and open to the waste line. This has to happen real fast, fast valve action, so we accomplish this with rubber pinch valves. So normally this one's open, this one's closed, and when I go to backwash it by actuating the actuator valve, it's going to pressure this one closed and open this one to the waste line. Gives me real fast action. Plus, remember, when I close this and open this, the clean water coming out of the one still online is actually doing the backwashing here. Back from scratch, water coming in, being split, going through both filters, being filtered, collected, back to the system. Time to backwash, close this, open this in one movement, just like that. Stops the flow here, takes clean water through the filter backwards, which would be a radial flow, sends it onto the waste. Quick pulse backwash, 15 seconds later, go back online. This is closed, this is open, everything's fine. Go to the next filter online, that would be this one. Now we're going to close the incoming water, the unfiltered, open the waste. It's going to take clean water from this guy, go through it backwards, backwash to waste. We do it with just the turn of a valve. Now we've got backflow through the second filter to the waste line. 10-15 seconds, it's radial flow, it's fast. Back online. Nothing to it. Okay folks, now we're inside the radial flow filter. The media container is composed of 2 hemispheres that are connected together with the rubber bellow, and the rubber bellow keeps the granular media captivated within the sphere. And it can be down and compacted, or it can be up for backwash, and you watch that happen with the position indicator when I had it up and running. Down, up. These will be included on the production units to let you know a barometer of how the operation is going, and when you've had enough attrition to the media that you don't have enough compaction and need to replace it. Now, in the filtration mode, there's a spring that's putting compaction pressure all the time, whether there's flow or no flow, onto the media. holding it at minimum void. During filtration, these little holes here, which were calculated by us, put a delta P as the water goes from the outside to the inside of the container. That adds additional force, which is actually in the tonnage. Now you ask, how does it go up and uncompact in the backwash cycle? When you reverse the flow, the delta P is backwards, and it actually overcomes the spring and lifts this up all the way. How's the water collected? In the center. I mentioned the inner drain. Here it is, opened up. It's also composed of two hemispheres of double screen that are connected into a sphere at the center of the media container. As the water comes in filtered, it passes through the screen, goes in this slot between the backwash ball and the inner drain, and out the pipe at the bottom filtered. When you reverse the flow in the backwash cycle, there's a shuttle valve which has a web, and when the water goes the opposite direction, it pushes the valve up and it closes the flow to this spot here, and the backwash ball will have jets drilled into it in a helix pattern that create the 16 foot per second velocity, high velocity backwash that quickly, in a water stingy fashion, backwashes the media in a very chaotic and turbulent backwash cycle. Then when you go back to normal flow, the valve comes back down, reopens this, filtered water comes in, enters the slot, out the pipe in the bottom. This initial prototype was built in a 24-inch filter tank that normally was designed for sand and had a peak flow of 68.5 gallons per minute. As a radial flow, it had 3-inch pipes. It had a peak flow of 210 gallons per minute. The future units we intend to build are smaller. We intend to build a 100 gallon per minute that'll be housed in an 18-inch diameter tank, and a 20 gallon per minute that'll be housed in a 10-inch diameter tank.